So next slides are about TCP segments. So how TCP normally delivers data to its end users. That is a TCP segment. So first we have the IP packet, we have a TCP packet, and we have a TCP segment which is being put together. So in case of IP packet, not bigger than a maximum transmission unit. So maximum transmission unit normally refers to the capacity of that particular channel. Up to 1500 bytes can be taken in a Ethernet channel. Now in case of a TCP packet, IP packet with a TCP header and data will be put inside. That is, normally we call the phenomenon as encapsulating the packet. Now TCP header is considered to be typically 20 bytes long. And whenever you consider TCP segment like IP packet which has a maximum transmission unit, TCP segment also has a maximum segment size. It can be only up to this particular segment the data can be delivered. So up to 1460 consecutive bytes from the stream of data is normally being delivered from the end user to the other side. Now we have one of the most important feature in TCP as a TCP three-way handshake. So what exactly is three-way handshake? Now in case of a three-way handshake, normally it is used in order to establish a connection between the client and the server. So the client normally sends a request to the server asking whether the server is ready to accept the connection. If so, the server sends a reply back, and in that case the client will start transmitting the data. So here normally the data packets are sent in the form of sync and sync acknowledgements. So we have got two hosts, host A and host B. Host A initially sends a sync request asking that it wishes to open the connection with host B. Now host B, if it is ideal, it can send a sync acknowledgement request reply back to the client. Host A sends an acknowledgement to acknowledge the sync acknowledgement. Now what if the sync packet gets lost? So sync is actually considered to be the packet that initiates a TCP connection. Now what happens if that particular packet is being lost? Suppose a sync packet gets lost. Packet is lost inside the network, or the server rejects the packet. That is, it will be listening checking that the queue is full. Eventually no sync acknowledgement will be arriving from the opposite side. Sender sends a timer, waits for the sync acknowledgement, retransmit the sync acknowledgement if needed. How should the TCP sender set the time? So the timer will be set on both the client side as well as on the server side. The sender has no idea how far away the receiver is. How to guess a reasonable length of time to wait? Some TCPs use a default of normally 3 to 6 seconds for data transmission. So this is how basically a TCP establishes the connection with the end user, basically by the concept of SYN segment.